According to National Electrical Code Section 250.50 and 250.53a, grounding electrodes must be connected to the grounding electrode conductor at the service equipment. Using branch electrical metallic tubing, or IMT, with a compression strap is not an approved method for grounding, as it does not provide a continuous and reliable path to the service equipment. In rural areas where there is no authority having jurisdiction or National Electrical Code adaptation, it is possible that local practices may deviate from National Electrical Code requirements. However, it is still important to adhere to safety standards to minimize the risk of electrical shock and fire. In the absence of an authority having jurisdiction or National Electrical Code adaptation, it is recommended to still follow National Electrical Code guidelines for grounding. This means connecting the grounding electrode conductor to the grounding electrode at the service equipment. Using branch electrical metallic tubing with compression straps for grounding can create potential hazards. Firstly, there is insufficient grounding. The connection may not be reliable, resulting in inadequate grounding. Secondly, ground loops can be created. Multiple grounding points can create ground loops, which can interfere with proper operation of electrical equipment. Thirdly, there is a risk of electrical shock. Poor grounding can increase the risk of electrical shock to occupants. While local practices may differ in rural areas, it is strongly recommended to follow National Electrical Code guidelines for grounding. Using branch electrical metallic tubing with compression straps is not an approved method and can pose safety hazards. Grounding is a critical aspect of electrical safety, designed to protect people and equipment from electrical shock and fire hazards. A properly installed grounding system provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices such as circuit breakers or fuses to quickly interrupt the circuit and clear the fault. This rapid clearing of the fault minimizes the duration of the electrical shock hazard and reduces the potential for equipment damage or fire. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding and bonding electrical systems. These guidelines are based on years of experience and research and are designed to ensure the safety of electrical installations. Adhering to the National Electrical Code requirements is essential for minimizing the risk of electrical hazards. The grounding electrode system is a crucial component of the overall grounding system. It provides a connection to the earth, which serves as a reference point for voltage stabilization and fault current dissipation. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, that are connected together to form a low impedance path to earth. The grounding electrode conductor connects the grounding electrode system to the service equipment, providing a path for fault current to return to the source. The National Electrical Code specifies the minimum size and type of grounding electrode conductor based on the size of the service entrance conductors. Bonding is another important aspect of electrical safety. Bonding involves connecting together all metal parts of an electrical system, such as metal conduits, metal enclosures, and metal equipment frames, to create a low impedance path for fault current. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electrical shock. The equipment grounding conductor, or EC, is used to bond together the metal parts of an electrical system. The equipment grounding conductor is typically a wire that runs along with the circuit conductors and connects to the grounding terminal of receptacles and equipment. The equipment grounding conductor provides a path for fault current to return to the source in the event of a ground fault. In rural areas, where electrical systems may be less frequently inspected and maintained, it is especially important to adhere to the National Electrical Code grounding and bonding requirements. Rural electrical systems may be subject to greater variations in voltage and current, and the risk of electrical hazards may be higher. In the absence of an authority having jurisdiction, it is the responsibility of the installer and the homeowner to ensure that the electrical system is properly grounded and bonded. One common misconception is that grounding can be achieved by simply connecting to any available metal object, such as a metal water pipe or a metal fence post. However, this is not an acceptable grounding method and can actually create a greater risk of electrical shock. A proper grounding electrode system must be installed in accordance with the National Electrical Code requirements. Another common mistake is to use branch electrical metallic tubing with compression straps as a grounding electrode. This is not an approved method because the connection between the electrical metallic tubing and the compression strap may not be reliable, and the electrical metallic tubing may not provide a low impedance path to earth. Additionally, using multiple grounding points can create ground loops, which can interfere with the proper operation of electrical equipment. Ground loops occur when there are multiple paths for current to flow between 2 points, creating unwanted circulating currents. These circulating currents can cause noise and interference in sensitive electronic equipment. To avoid ground loops, it is important to ground all equipment to a single point, typically at the service equipment. In conclusion, proper grounding is essential for electrical safety. Adhering to the National Electrical Code grounding and bonding requirements is crucial for minimizing the risk of electrical shock and fire hazards. In rural areas, where electrical systems may be less frequently inspected and maintained, it is especially important to follow the National Electrical Code guidelines. Avoid using unapproved grounding methods such as branch electrical metallic tubing with compression straps, and ensure that all equipment is grounded to a single point to avoid ground loops. The importance of a continuous and reliable ground path cannot be overstated. It is the foundation upon which electrical safety is built. When a fault occurs, such as a short circuit, a properly installed grounding system provides a low impedance path for the fault current to return to the source. This allows the overcurrent protection device, like a circuit breaker, to quickly trip and interrupt the flow of electricity. Without this low impedance path, the fault current may not be high enough to trip the breaker, resulting in a sustained fault that can lead to overheating, fire, and electrical shock. The National Electrical Code emphasizes the need for a permanent and effective ground path. This means that the grounding conductors and connections must be sized and installed correctly to withstand the potential fault currents. The connections must be tight and corrosion resistant to ensure a long-lasting and reliable ground path. In areas where the soil is dry or rocky, it may be necessary to install multiple ground rods or use other grounding techniques to achieve the required ground resistance. The ground resistance is a measure of how well the grounding system is connected to the earth. The lower the ground resistance, the better the grounding system will perform in dissipating fault currents. The National Electrical Code specifies the maximum allowable ground resistance for different types of electrical systems. Regular inspections and testing of the grounding system are essential to ensure its continued effectiveness. Ground resistance testing can be performed using specialized equipment to measure the resistance between the grounding electrode and the earth. Visual inspections can identify any loose connections, corroded conductors, or other problems that may compromise the integrity of the grounding system. Addressing these issues promptly will help maintain a safe and reliable electrical system. In addition to protecting against electrical shock and fire hazards, a properly installed grounding system can also improve the performance of electronic equipment. Sensitive electronic devices are often susceptible to noise and interference from electrical transients. A good grounding system can help to filter out these transients, providing a cleaner and more stable power supply for electronic equipment. This can result in improved performance, reduced downtime, and longer equipment life. Grounding practices also extend to the proper bonding of metallic enclosures and equipment. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential. This eliminates the possibility of voltage differences between metallic parts, which could create a shock hazard. The National Electrical Code specifies the bonding requirements for different types of electrical equipment and enclosures. These requirements are designed to minimize the risk of electrical shock and ensure the safety of personnel working on or near electrical equipment. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses. It also includes energizing circuits before working on them and using lockout/tag-up procedures to prevent accidental re-energization. By following safe work practices, you can minimize the risk of electrical shock and other electrical hazards. Continuous education and training are also essential for staying up to date on the latest electrical safety practices and national electrical code requirements. The electrical industry is constantly evolving, with new technologies and regulations being introduced regularly. By participating in continuing education courses and training programs, you can ensure that you have the knowledge and skills necessary to perform electrical work safely and effectively. This commitment to safety will benefit not only yourself, but also your customers and the community as a whole. Remember, electrical safety is everyone's responsibility. By understanding the principles of grounding and bonding and following safe work practices, you can help to create a safer electrical environment for yourself and others. Grounding and bonding are not just theoretical concepts, they are practical measures that can save lives and prevent property damage. In conclusion, proper grounding methods are crucial for ensuring electrical safety, preventing electrical shock and fire hazards, and improving the performance of electronic equipment. Adhering to the National Electrical Code guidelines, using approved grounding techniques, and regularly inspecting and testing the grounding system are all essential for maintaining a safe and reliable electrical system. Remember, electrical safety is a shared responsibility, and by working together, we can create a safer electrical environment for everyone. The National Electrical Code Section 250 provides comprehensive requirements for grounding and bonding electrical systems. This section covers a wide range of topics, including grounding electrode systems, grounding conductors, bonding conductors, and equipment grounding. Understanding and complying with the National Electrical Code Section 250 is essential for ensuring the safety of electrical installations. The grounding electrode system is the foundation of the grounding system. It provides a connection to the earth, which serves as a reference point for voltage stabilization and fault current dissipation. The National Electrical Code specifies the types of grounding electrodes that are permitted, as well as the requirements for their installation. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The grounding electrode conductor connects the grounding electrode system to the service equipment. The National Electrical Code specifies the minimum size and type of grounding electrode conductor based on the size of the service entrance conductors. The grounding electrode conductor must be securely connected to both the grounding electrode and the service equipment. Bonding is the process of connecting together all metal parts of an electrical system to create a low impedance path for fault current. The National Electrical Code specifies the bonding requirements for different types of electrical equipment and enclosures. Bonding helps to ensure that all metal parts are at the same electrical potential, minimizing the risk of electrical shock. The equipment grounding conductor, or EG, is used to bond together the metal parts of an electrical system. The equipment grounding conductor is typically a wire that runs along with the circuit conductors and connects to the grounding terminal of receptacles and equipment. The equipment grounding conductor provides a path for fault current to return to the source in the event of a ground fault. The National Electrical Code also addresses the issue of ground loops. Ground loops can occur when there are multiple paths for current to flow between 2 points, creating unwanted circulating currents. These circulating currents can cause noise and interference in sensitive electronic equipment. To avoid ground loops, the National Electrical Code requires that all equipment be grounded to a single point, typically at the service equipment. The National Electrical Code also provides specific requirements for grounding and bonding in different types of occupancies, such as residential, commercial, and industrial buildings. These requirements are tailored to the specific hazards and conditions that are present in each type of occupancy. In addition to the National Electrical Code, there may also be local codes and regulations that govern electrical installations. It is important to check with the local authority having jurisdiction to determine the specific requirements that apply in a particular area. Proper grounding and bonding are essential for electrical safety. By understanding and complying with the National Electrical Code requirements, you can help to ensure the safety of electrical installations and minimize the risk of electrical shock and fire hazards.